Hey, we're in week 3. This is part 2. All right, so a lot of this we're going to be using a website. It's linked onto your Google Doc. I'm not going to go through the answers that you can just grab from there, but I will just walk through it just to make sure it's clear. So click on that link. Make sure you set the population proportion to 0.5, confidence level to 95%, and sample size to 75. Click sample, and then it'll show you the resulting confidence interval. The confidence interval is displayed as a horizontal line segment with a dot representing the sample proportion in the middle of the interval. The true proportion is the green vertical line. Did your first confidence interval capture the true proportion? So what we're looking for here is, we've got a vertical line. I did this website the other day, but I don't totally remember what it looks like. There's going to be a horizontal line. That's your confidence interval. If this is what you get, you would say no, because your confidence interval does not go through the line. Most of the time they will. So most of you will be saying yes for this. You might get like one person might say no. Repeat this 10 times and put a screenshot of what you see right here. And then I want you to tell me how many of your intervals capture the true proportion. So what this will look like is it'll be like 10 horizontal lines in different places. Most of them, if not all, will go through that green vertical line. You're just counting how many of your horizontal bars actually go through it. Okay, I want you to reset, and then I want you to take a total of 100 confidence intervals. To do that, you can sample 25 4 times. How many out of those 100 captured the true proportion? Your answers for this are going to vary. You're probably going to get something around 94, 95, 96%, most likely. And as far as, is that surprising? It shouldn't be. Our confidence level was set to 95%. So what that means is that 95% of the confidence intervals will contain the true proportion. Okay. Question 4. Watch your confidence intervals as you drag the confidence level from 95 to 99%. Don't reset it. You're just changing the confidence levels. What happens to your intervals, and why does this make sense? Go ahead and try that and ponder why that might make sense. So you're like, what's happening and why does that seem like it makes sense? Okay, so your intervals, hopefully what you were seeing is that they were getting wider. And the reason why is that we need wider intervals in order to be more confident. So the intervals got wider, more of them capture the true proportion. You need to have wider intervals in order to be more confident. All right, reset it and then sample 100 times at an 80% confidence level. What percent of intervals now capture your true proportion? Hopefully you're getting something similar to 80%, maybe 81, maybe 79, maybe a little further off from 80, but should be pretty close to 80. Okay, so what this is going to tell us is that 80% of the intervals contain the true proportion. Great. Now we're going to mess around with sample size, see what happens with that. Change your sample to 20 and sample for 1 interval. Then change it to 250 and sample for 1 interval. What happens to the interval when the sample size is increased? We've talked about this a little bit, but hopefully what you're seeing is that the interval is much narrower. We didn't really talk about that part, but what we have talked about is as sample size increases, the variability of the sampling distribution goes down. All right, so that was sort of fast just because most of it was kind of work on your own on the website. So make sure you did all that stuff. We're going to go ahead and go over some notes. Okay, first part is how to interpret a confidence level. What we can say is if we take many, many samples and calculate a confidence interval for each one, about blank percent, whatever your confidence level is, will capture the true parameter. And either we're going to be talking about proportions or means in context. Okay, and then there's a couple, that's like the main idea for this, a couple other little details. When we're talking about margins of error, a couple things to add to our understanding for that. As your confidence level increases, your margin of error increases. That's going to be a wider interval. And then the other thing is as your sample size increases, your margin of error decreases. And that means it'll be a narrower interval. And that's what we saw near the end of the activity for this part. And then last thing here is just more about margins of error. So maybe I didn't need this little division. Put some bullet points in here. There we go. Margin of error does account for random variability. Maybe some samples are just going to be a little bit off, a little too high or a little too low. Margin of error does account for that, but it does not account for bias. If your sampling method is biased, your margin of error is not going to help you with that. So if you have, like, if you remember back to our project, if you have non-response bias or under coverage bias or response bias, under coverage, margin of error is not going to help you understand that. It's just going to account for random sampling variability. All right, I want you to go ahead and try the check for understanding. Please pause this video now, and when you're ready, hit play to go over the answers. All right, for part A, this is pretty much just like fill in the blanks from the notes, but I'll go ahead and go over it. If the gym teacher takes many, many samples and calculates a confidence interval for each, about 90% of them would capture the true, and here I'm going to use context, the true mean number of push-ups for students at the school. All right, and then explain what would happen to the length of the interval if the confidence level were increased. So looking back at our notes, if you increase the confidence level, that means that the length will increase because margin of error is increasing. So your intervals will become wider because your margin of error is increasing. Okay. Next question, if now it's sample size of 200, your intervals will become narrower, meaning that your margin of error will decrease. And then one potential source of bias that's not accounted for by the margin of error. Few right answers here. I would say undercoverage is a big one. Because students who, I'm not going to write all this out, but you can just listen. Students who are not after school athletes did not have a chance to be part of the sample. So it's not going to be a true representation of the whole school. All right, we're done with part 2.